begin talking about the pentose phosphate pathway, there are two separate sections of this pathway. There's the oxidative and the non-oxidative. To begin, the oxidative pathway begins with glucose 6-phosphate, which is then reacted with NADP+ to create 6-phosphogluconolactone and NADPH. Glucose 6-phosphate dehydrogenase catalyzes the oxidation of the aldehyde of the glucose 6-phosphate to a carboxylic acid as shown in the pictures. This is the committed step of the pentose phosphate pathway. Next, 6-phosphoglucolactonase catalyzes the hydrolysis of the ester linkage, resulting in the ring opening. The product is 6-phosphogluconate. Although the ring opening occurs in the absence of the catalyst, this catalyst speeds up the reaction, decreasing the lifetime of the highly reactive, potentially toxic 6-phosphogluconoacetone. 6-phosphogluconate is then reacted with NADPH, which acts as an electron acceptor to pull off one of the hydrogens. It is then reacted with phosphogluconate dehydrogenase, which catalyzes the oxidative decarboxylation that yields a 5-carbon ketose, ribulose 5-phosphate. The hydroxyl group at the third carbon is oxidized to a ketone. This allows the carboxyl at the first carbon to be removed as carbon dioxide. This is the end to the oxidative section of the pentose phosphate pathway. Next, ribulose 5-phosphate is used in two different types of reactions. The first shown is with an epimerase, which interconverts the stereoisomers ribulose 5-phosphate and xylulose 5-phosphate. Next, isomerase converts the ketose in ribulose 5-phosphate to an aldose, ribulose 5-phosphate. Next, xylulose 5-phosphate and ribose 5-phosphate are reacted together with the trans ketose, which takes 2 carbons from the xylulose 5-phosphate and adds them to the ribose 5-phosphate to create glyceraldehyde 3-phosphate and pseudoheptulose 7-phosphate. Next, glyceraldehyde 3-phosphate and pseudoheptulose 7-phosphate are reacted together with transaldose to create fructose 6-phosphate and urethro 4-phosphate. 3 carbons from the pseudoheptulose 7-phosphate are added to the glyceraldehyde 3-phosphate to make these products. Fructose 6-phosphate is then used directly into the glycolysis cycle, whereas urethro 4-phosphate is reacted again before it can enter the glycolysis cycle. Finally, erythrose 4-phosphate and xylulose 5-phosphate are reacted with the transketolose to create glyceraldehyde 3-phosphate and fructose 6-phosphate. A carbon from the erythrose 4-phosphate is added to the xylulose 5-phosphate to create these products. Both glyceraldehyde 3-phosphate and fructose 6-phosphate may now enter the glycolysis cycle to be used by the cells. This concludes the brief overview of the pentose phosphate pathway, both oxidative and non-oxidative pathways, as well as their products. This shows the mechanisms for how the various products and intermediates are formed in these steps and explains how the products from each step are used to continue the pathway or go into glycolysis. Thank you for watching my video, and I hope it gave you a little bit more understanding of the pentose phosphate pathway and how it is used by the body and the steps in which the cells take to create the products they do, and then how they are further used by the cells in glycolysis to create energy.